Notes 5, limits galore. You guys ready?
No.
So we've been doing limits all these last 2 weeks. We've been doing limits these last 2 weeks. So now let's see if we can put all the different types of ways together so we can see if we can knock these out. All right, I hope you guys are happy. Here we go. Letter A. Can we do direct substitution on that one? Yes. I can do direct substitution. I just go right into it. 2 minus 4. Negative 2. 2 squared. 4 plus another 2. So 6 plus another 2. Don't leave it as negative 2 over 8. Reduce that. Reduce it to what? Negative 1/4. How do we feel? Okay. Next one. Can we do direct substitution on that one? No. Notice that if you do direct substitution, you get 0 over 0. If you get 0 over 0, you have a limit. 99.9% that you're going to have a limit. I guess that's called indeterminate form. We'll talk about that when we get to L'Hopital's rule. We're not there yet. So here we go. So we got to do something else. Either graph it, but it says without a calculator, so we got to do it without a calculator. So we're not going to graph it then. What are we going to do? Expand it? All right. So I write the word limit because I haven't evaluated it yet. And the top is the difference of, so what am I going to write? And on the bottom, two numbers that multiply give you negative 6, but add it up to negative 1. Yep. X plus 2, x minus 3. Now that I have it written this way, is there a factor that I can cancel out? X minus 3, so cancel these factors out. Now can I do direct substitution? I can. 3 plus 3. 3 plus 2. There it is. That's my limit. How do we feel? All right. Notice this one is going to be, okay, limit as x approaches 2 of x plus 3 over x minus 2. Can I do direct substitution? No, but I get a number over 0, so I can just write what? Does not exist. How do I know when I have one that does not exist and one that does actually have a limit? When you can't expand, okay, I guess. I mean, remember this one had 0 over 0, but it had a limit, and then this one had a number over 0 when I plugged in direct substitution. So if you get a number over 0, it's probably a vertical asymptote. And it is. Look, it's x plus 3 over x minus 2. That one looks like this. At 2, you have a vertical asymptote. To the right of this, it's positive infinity. And it actually has a horizontal asymptote of 1. Hopefully, this is all good stuff that you already know. It goes down forever, and it goes like that. How did I know that it has a horizontal asymptote of 1? How did I know that just by looking at it? X over x is 1. So hopefully you're putting your Algebra 1 skills or your Algebra 2 skills together with your calculus skills. How do we feel? Good. All right. Let's go to the next one. This one, again, does not exist, but it does have a common behavior. So I'd rather have the behavior than does not exist, but I guess worst case scenario, it's a number over 0. Does not exist. You can always put does not exist for safety. But what if that answer is not in the multiple choice? This has a horizontal asymptote of 0, but as you approach 2 from the right-hand side, it's positive infinity. And if you approach 2 from the left-hand side, it's also positive infinity. How did I know that? How did I know that I just magically just know this equation? Yeah, I didn't just magically know this equation. It's because of what? Like, how do I know that it's approaching positive infinity? When you have something that's being squared, it's always going to be positive. Look at the numerator. 2 plus 3 is 5. So even if I approach 2 from the left for the expression x plus 3, I'm approaching the positive number 5. If I approach 2 from the right for the expression x plus 3, I'm going to be approaching 5. So no matter what, in the numerator is going to be like 5. But in the denominator, if I choose like 1.9, 1.9 minus 2 is negative 0.1. Negative 0.1 squared is going to be a positive small number. If I go 2.1 minus 2, well, that's always positive anyways. But see how if I put a number to the left of 2, that it's still going to be positive? So you're dividing by a super small positive number. So that's how I know that both behaviors approach positive infinity. So I could write positive infinity. Does not exist is also a valid answer, but I think that one's better. Are we okay? Okay. All right, Machan, hook me up with this one. And it's okay if we get it wrong, but I have faith. Limit as x approaches infinity of 3x minus 5 over 2x plus 4. And relax. And if we're wrong, it's okay, miss. Don't worry about it. Yeah, don't know. Unless there's a lifeline, but there's not a lifeline right now. Not yet. What do you think? Okay. I'll give you a hint. End behavior.
Thank you. So then you basically just take off the end too.
Okay. So what is it? Yes. That's also your horizontal asymptote. So if someone asks you, what's the horizontal asymptote? Oh, some of you guys did this on your homework yesterday. You just put horizontal asymptote, you just put 3 over 2. Guys, if it's horizontal asymptote or vertical asymptote, you have to have a letter. Horizontal asymptote, you got to say y equals. If it's a vertical asymptote, you got to say x equals. If you just type in a number, I don't know what that is. Is it a y equals or is it an x equals? You got to say y equals something if it's a horizontal asymptote. Cool or not cool? All right. Letter F. 4x plus 7 in the numerator, x squared minus 3x plus 5 in the denominator. What is my limit? All right, which one's bigger? Denominator or numerator? So which one's growing faster, denominator or numerator? Denominator. So a number divided by an even bigger number. What is that going to approach? 0. Does that make sense, guys? All right. I think you guys are pretty good about graphs because that's what you guys had a very strong performance in. So let's do this together. Limit as x approaches infinity for g of x. This whole graph is g of x. As I approach infinity, what does it look like? -3. You're looking at this guy down here. Letter B. What happens if you approach negative infinity? I should have put arrowheads. I'm sorry, guys. 0. Letter C. How do I read that? -3 from the left. So go look at -3. X equals -3. Positive infinity. That's the behavior. You can also say what? Does not exist. What about letter D? -3 from the right. Negative infinity. It's going down forever. What about letter D? Oh, I put 2 letter D's. D number 2, I guess. D2. I'll fix it next year. What happens as x approaches 0 from the left? 0. Good job. Okay, I'll put it here. Fix. Next year. And I will literally fix it next year at this time when I look at this. Oh, I gotta change this. All right, no, I'll probably change it this time like before. All right, letter E. If you approach 0 from the right, what is it? Positive infinity. Letter F. If I approach 4 from the left. Letter G. If I approach 4 from the right. Good job. Excuse me. That was a hiccup. All right. Y'all ready? Relax. They're not even that bad. No, this one's not a... You only do the spin and ocean if you approach infinity. You're not approaching infinity for any of these right here. So here we go. Can I do direct substitution in letter A? No, but I do notice something about the numerator. That is the what? What of cubes? It's not. Is there a minus sign? There's a plus sign, so don't call it difference. Call it the sum of cubes. The sum of cubes is just like the difference of cubes. I'll write it right here. Yeah, a cubed plus b cubed equals, parenthesis, a plus b, close, open, a squared minus ab plus b squared. That's the sum of cubes. The difference of cubes, I'll write it in here because you'll probably need it. A cubed minus b cubed equals a minus b, close, open, a squared plus ab plus b squared. Chop, do I got to memorize that forever and ever and ever? At least for the next 5 or 6 years. Because you guys are going to be engineers and future doctors, and yeah, you're going to be coming across all types of stuff. All right, here we go. Ready? I can't do direct substitution, so I got to do some algebraic manipulation. Don't worry, I'm going slow. As x approaches -2, notice my habits. Not all my habits are good, but here's, try to make sure that there's a good habit here. Sometimes I drop the limit. Don't drop the limit. We're still writing the expression. X plus 2, close. No one's freaking out. 2 cubed is 8. Open. X squared minus 2x plus 4, close. All over x plus 2. I notice that I have a common factor. What can I cancel out? Now I can do direct substitution. So let's see. -2 squared is 4. -2 times another -2 is another 4, plus 4. So 4 plus 4 plus 4, what's that? There's my limit. How are we feeling? All right, letter B. Do you notice something there? You could multiply by the conjugate, which we've done in the past, and it would work, which is actually what we're going to do with letter C. But I see an easier way for letter B. So here's what I notice. Technically, I guess you got to use the word perfect. Technically, any two things can be the difference of squares. Technically. Now, whether it's a perfect square or not is a different issue. So usually we're looking for perfect squares. But look, square root of x times square root of x is x. And 2 times 2 is 4. And notice that in the numerator, I got square root of x minus 2. So I can factor out the denominator. Right? You can do this. You can make it look like the difference of squares, guys. Limit as x approaches 4, and the numerator, leave it alone. But the denominator, what am I going to write? Yeah, you said it right. Square root of x plus 2. Oh, you don't like that?
Oh.
Square root of x times square root of x is x, and 2 times 2 is 4.
X squared plus like 4 something is kind of
If you don't like that, you can multiply by the conjugate, multiply by square root of x plus 2 over square root of x plus 2, and you'll get your x minus 4. Are we okay, guys? All right, what cancels out?
square root of x.
Now you still have a numerator. The most algebraic error that I see is that you guys just write, let's see, what's the limit as x approaches 4? Okay, so for the square root of 4, man, I just said everything wrong. What's the limit as x approaches 4? And then I just square root of 4. If I plug in a 4 into this, which now you can do direct substitution, square root of 4 is 2, and 2 plus 2 is 4. So the most common error I see is that you guys just write, oh, that's 4. It is not 4, it is 1 over 4. Oh, because I can't do direct substitution. So I had to look at it and be like, hey, that looks like the difference of squares. There's other ways. You don't have to do it. You want to see the other way? Okay. I'm going to write the other way right here, guys. You could have done it like this. Limit as x approaches 4. And then I'm going to have square root of x minus 2 over x minus 4. You could have done this. You could have gone times, and then the conjugate of the square root of x minus 2. So x plus 2 over the square root of x plus 2. So now, in the numerator, that just looks like this. Limit, as x approaches 4, of x minus 4 over, and then don't distribute the bottom, just leave it like that. See? Let me put the plus out like that. And now look what cancels. The x minus 4s, and you get the same answer. Right? It doesn't matter which way, they both work. How do we feel? Okay. All right, here we go. Letter C. Oh, Chav, I don't know what to do on that one. You're going to multiply by the conjugate. Square root of x plus 16, and then change that minus to a plus, and then just make it both numerator and denominator the same thing. Like that. Why does it work? Because it's like the difference of squares. A plus ba minus b, which is a squared minus b squared. So the square roots go away. So limit as x approaches 0. You can't do direct substitution because of the denominator. So I'm going to have x plus 16 minus 4 times 4 is 16 over, and then you have x times square root of x plus 16 plus 4 close. So catch up to here and then we'll talk. What happens to those 16s in the numerator? They zero out. Good job. Good job with the zero out. They zero out. Now that you've zeroed out the numerator, now you can cancel out a factor, which is what? That x. And now can I do direct substitution? Yes. 1 over, not 16. The square root of 16 is 4, and 4 plus 4 is 8. You plug in a 0 into the square root of x plus 16. You get the square root of 16, which is 4, and 4 plus 4 is 8. How do we feel? All right. He's actually pretty simple. You'll see when we get to it. Letter D. Letter D. Do we know what letter D is? Can we visualize this? No? Yeah, let's try to visualize it. Nope. Okay. All right, guys, let's go slow. If you're talking about a number larger than 0, this is just x over x. So this is like saying y equals absolute value of x over x. How would this function look like? Well, if it's a number bigger than 0, the absolute value of all positive numbers is itself. So 5 divided by 5, 10 divided by 10, 100 divided by 100. What are all those numbers going to be? Yeah, 1. All of them. 5 divided by 5, 10 divided by 10, 100 divided by 100. So obviously I'm not defined at 0, right? So I have a circle like that, and then I go forever like this. That's a 1. That's only if for the positive numbers. Does that make sense? All right. Now, what if I have a negative x value? Negative 1, because the numerator is always going to be positive. The absolute value of negative 10 is 10, but I'm dividing by the negative 10, by the magnitude of that. So 10 divided by negative 10. 100 divided by negative 100. 1,000 divided by negative 1,000. It's always going to be. So I go to negative 1, and I go forever that way. Do we see how we did it? Okay, so now that we know, if I approach from the right, the limit is 1. If I approach from the left, the limit is negative 1. So what is it? What is this limit? Does not exist. Actually, prefer to write it out instead of D and E. Does not exist. Everyone knows the acronym D and E, but it's preferred to have better habits, right? Does not exist. All right. Check out this awesome problem. Relax on letter E, relax. It's not even that bad. It looks bad, but it's not. Can I do direct substitution? No, this one is stopping you from direct substitution. That one gives you 0 over 0. Do you guys see that? You don't see that? If I plug in a 2, 2 minus 2 is 0. 2 squared is 4, minus 2 is 2, minus 2 is another 0. So you get 0 over 0, so that you can't do that. So, yeah, well, we don't care about the x to the fourth because 2 to the fourth is a number. Okay, so we need to figure out what to do with that. So go to the side and write x minus 2 over, and then my factors for the denominator. X minus 2, x plus 1. I was trying not to.
I'm sick, he says.
I'm not. I don't have a runny nose like I have. I'm still stuffy, but I'm not sick. Is that considered sick? All right. All right, here we go. Here we go. Ready? What cancels out? Now that I canceled out the x minus 2, now can I do direct substitution? Yes. So let's see. 3 to the power 2 plus sine of 2 pi over 2 to the 4th power plus 1 over 2 plus 1. I'm just getting it from here, right? 1 over x plus 1. Let's see what that is. 9. What's sine of 2 pi? Oh, man. I was your pre-cal teacher, too. 0. Sine of 2 pi is 0, guys. All right. Sine of 2 pi is 0.
Yeah, sine is a y value.
Yes, sine is a y value. 2 to the 4th. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So you should be able to do that at least. I just did 2 to the 4th. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Are we still okay?
Yes.
Plus 1 plus 2 over 1. That's 1/3. Usually you don't want to have stuff looking this ugly. Usually you want to figure out what this is, like a nice, pretty fraction or something. So let's continue. 9 over, the way to do this, what's 16 times 3? 16, 32, 42, 48. 48 over 3. I make mistakes all the time, so check that I'm right. 16, 32, 42, 43, 45, 46, 47, 48. It's right. 48 over 3. 48 plus 1. So 49 over 3. Keep, change, flip. 27 over 49. A nice, pretty fraction.
Not a very pretty one, but
Oh, they're both 27 and 49 are nice numbers. They've never not been nice to me. Right. Oh, guys, this one? No, it's not this one. This next one. All right. So remember how I told you there's a super hard problem? It's not this one that's super hard, but you'll see there's one coming up. All right. So here we go. Are we on the next one? So the graph of the function f and g are shown above. The value limit as x approaches 1 for this function is. So how do I do this first? You're going to look at g. So limit as x approaches 1 for g of x. So look at g of x first. What is that limit? You're looking for the limit. You're not looking for the value of that function at 1, but the limit. 2. And I take that 2 and I put that in to the f, right? What is f of 2? There you go. I think in AB, that's about as hard as it's going to get. Do you want to see the hardest question that BC had last year? Do. All right, this one here. So you guys were getting this correct on that quiz, but guys, make sure you know how to do it or why it's true. All right, so look what it says. Given this cosine x and c is pi over 6, determine whether the limit as h approaches 0 of that expression exists and give the value of the limit does not exist. Okay, here's what you need. You need to figure out what f of pi over 6 is, and that one's easy to do. What's cosine of pi over 6? You guys remember from your pre-cal days? Cosine? Oh yeah, cosine it is. Sorry, for some reason I was about to put half. Yeah, cosine's the x value. And I need to know what f of pi over 6 plus h is. And that one we don't know because we have cosine pi over 6 plus h. But everyone in here took pre-cal, and that is why we need pre-cal. And we know what cosine of a plus b is, composite argument properties. Do you guys remember that? Cosine of a plus b is cosine a, cosine b, minus. All right, yeah, you guys know. Thank you.
I remember memorizing this and being very stressed for that.
So here we go. I'm gonna write limit as h approaches 0, and I'm just doing this right here. F of, I guess I'll write everything because you guys probably want to see everything, right? Pi over 6 plus h minus f of pi over 6 all over h. So I'm going to expand it. Limit as h approaches 0. And what's f of pi over 6 plus h? This guy right there. Cosine pi over 6 plus h minus, and f of pi over 6 is just square root of 3 over 2. All this is over h. Are we still okay? Okay, here we go. Okay. No, you're good, you're good. I'm going to expand the cosine pi over 6 plus h, guys. Limit as h approaches 0. And all I'm doing is this formula right here, that bullet. Cosine pi over 6, which in a little bit we'll reduce it by putting square root of 3 over 2. Cosine of h minus sine pi over 6 sine h. And then minus, that minus is this minus. Square root of 3 over 2 all over h. So catch up to there. All right, here we go. Cosine of pi over 6, you guys already told me that was square root of 3 over 2. Sine of pi over 6, you guys already told me that was 1/2. Limit as h approaches 0, and I'll write it for now, square root of 3 over 2 like so. Cosine h minus 1/2 sine h minus square root of 3 over 2 all over h. And I'll slow down so you guys can write. Are we still okay? Do you catch up? Do you have ketchup for my fries? I know. Limit. Oh, I love Dr. Pepper. H approaches 0. All I'm going to do is, and by the way, there's no equal sign, so I'm just moving this way and this way. You don't change the signs. I know every time I do this, I do. But I don't change the signs because there's no equal signs. I'm just putting them in different locations. I'm just sliding them. Square root of 3 over 2, cosine h, minus square root of 3 over 2, minus 1/2 sine h. All this is over h. I'm okay. Am I still okay, guys? All right, here we go. I'm going to factor out the square root of 3 over 2. Well, okay, you know what? That might freak you guys out. I won't do it yet. limit h approaches 0. And I'm putting it right here in front of this, square root of 3 over 2 with a parenthesis on it. Cosine h minus 1, close it, minus 1/2 sine h. All this is over h. It's because I was thinking about putting it in front of the limit already, but not yet, because I don't want to freak you guys out. Are we okay so far? Yeah, because it's just a constant, so I can just move it out. All right. Look, side note. Don't worry, I'm going to come back, guys. Side note. A plus B divided by C can be written as A over C plus B over C. Yes or no? Okay, and we know that, right? Okay, I'm dividing by one term, that H. So I'm going to rewrite it like this. Let me, to avoid.
Oh, that's what you did. I was like, I should get that. You factored out the square root of 3. I was like, I want to do it. So when you factor out, nothing disappears, right?
Say it again.
So like if you're given like 4x plus 4 and you factor out 4, it's going to be x plus 4 just times x.
4x plus 4.
Yeah, because like it won't disappear.
4x plus 4, factor out of 4, yes.
I was just like,
Are we still okay? Okay, I can write this like this, guys. So you can see the limit, the properties. So this is just a constant, and that half is just a constant. So I can write it like this. Square root of 3 over 2, limit as h approaches 0, and I'm going to write cosine h minus 1 over h minus 1/2, limit as h approaches 0, sine h over h. Do you guys still have on file your notes 2, the special limits? Look at them real quick. Oh, because it's not affecting, it doesn't have an h, so it's just a constant. It's a property of your upper properties from the limit properties. Look, let me go over here. Let me take out notes 2 so you guys can see. Calculus. It's this. You see this right here? You see how rule number 4. See how it says here the limit as x approaches c of f of x is just L, and then I have k times L. So I could have if I wanted to, I could have done this. I could have said k limit as x approaches c of f of x. And remember, this right here is L, which is sorry, which is your KO that they have there. So I can just bring that k to the front of that limit. Okay, sorry, just making sure. Here are the rules that I was talking to you guys. The special, I think it was on this one, was it not? Maybe it was notes 1? Yeah, I guess it was notes 1. I didn't think I introduced it in notes 1. No, notes 3. Notes 3. Oh, it's a big file. Yeah, I should have clicked on the one that's a small file. Look at your notes 3, guys. Well, this laptop is struggling to. Save. And it still hasn't downloaded a single thing. I'll go over here.
I mean, you are learning a lot of programs right now.
Okay, here's notes 3, unwritten. And it's right here under special limits. But I have a whole bunch of stuff in here that I told you that special, like this could look different. You guys remember? Okay.
Oh.
It doesn't have to be an X. It could be an H, like on this one.
Oh, I see something.
Okay, it's all
Oh,
right.
the sin x over x.
Yeah. So look on this one. Here we go. Limit. So I have the square root of 3 over 2. And I have this. What is this equal to? Yeah, I heard someone say it. That's 0. That's your special limit. As x approaches 0 of cosine x minus 1 over x. But instead of an x, they have an h in there. Minus 1/2. And what is limit as h approaches 0 of sine h over h? What is it? Look at your special limits. It's not 0.
It's 1.
It's 1. Yeah, limit as x approaches 0 of sine x over x. That's 1, guys. So, what's negative half times 1? And there it is. And some of you got it right on Trig Equations 5. And I was impressed that you did all that without having the notes.
I guess. Technically, I guess, but I guess
So-
I'm right.
So, yeah, guys, I'm telling you, I know you can always Wolfram Alpha everything, or, you know, math type or whatever app is new now that you can just hover. I know Microsoft Edge. If you have Microsoft Edge, I don't know if I should tell you this. Yeah, I know them all. I know Microsoft Edge now has where you can just hover over your the text, the math text, and it'll tell you an answer. I don't know if you guys knew that Microsoft Edge does that, but it does that.
I'm exposing
But try really hard. If you use it, that's fine, but don't use it just to take advantage of, let me just get my 100, because in the end, the grade doesn't mean anything, you know? Like you want to struggle, like, you know what I mean? Like, you want to qualify for college credit. So you're not going to have Microsoft Edge to do all that stuff, or, you know, whatever app. So come on, guys. Okay. Ready for this next one? Oh, were you still writing on this? Was that beautiful? I thought that was beautiful.
Oh, wait, that says, oh, right. Square root of 3 over 2 times 0 is just 0. How about that?
All right. Here we go, guys. You guys ready? I bet you the other one is still downloading. Oh, it said nope, couldn't do it. That's fine. That's fine. That's fine. It's because I am doing a lot of things at the same time. I'm mirroring, so the signal output. I am recording, so it's recording the mirror, and I am annotating, so yeah, I can hear the fans blowing, so it's getting really hot. So if I ask it to download, it might be too much. All right, here we go. This, good news for you, not tested on AP. To know. Because UH gives you this question, and I want you to get it right, but I think it's a good question to ask. I think this is why I'm telling you, okay, real quick, I need you guys to listen for like 10 seconds. Well, to listen for a while, but because this is important. The feedback I get from everyone that has taken the AP exam, every single kid, because every year I make my calculus do like a little Google form, and they can be anonymous if they want, or they can put their names. Most of the time they put their names. But the feedback I get every year is that the UH is harder than the actual AP exam. Every year I've been hearing the same thing. So that's why I tell you guys, I need you guys to struggle with the UH quizzes. Like, give it a real shot. And if you can struggle with that, that's what builds up your stamina. Your neurons in your brain, in your head, they're making that connection. If you can work through UH, then by the time that real AP exam comes, like, man, this is a joke. They've all told me, text one of the previous, or talk to your current buddies that are in BC. Like, did you think the Cal BC, the UH quizzes are harder than the AB exam? And they'll tell you, like, oh yeah, the UH quizzes are harder. So that's why I try to sweat through the UH quizzes. Okay. Relax on this one. It's not tested, but it is on the UH, so let's talk about it. This is the delta. It's just a lowercase delta. I know you guys are used to seeing the delta with a triangle. This is a lowercase delta. Lowercase delta. And this is called an epsilon, and it's a lowercase epsilon. And let's see what it says. For the following limit, find the largest delta that works for epsilon equals 0.01. Relax. This epsilon just means error. Can't even spell error. Error. So what does it mean? It means, this is what it means. How close does x over 2 need to be to 2 so that the error will be 0.01? That's what it means. How close does x over 2 need to be to 2 so that the error will be 0.01? Well, actually, it means a little, well, okay, you'll see what I mean. How do we feel right now, guys? Do we feel okay? All right, so here's what we got to do. We want the error between x over 3 and 2/3 to be how much? 0.01. So that's what I'm going to do. I'm going to put an absolute value, and I want the error between x over 3 and 2/3 to be at least 0.01. Are we still okay so far? All right. Oh, because error doesn't matter if it's negative or positive. So as long as I'm 0.01 away, I can be 0.01 to the right or 0.01 to the left. All right. So absolute value, x minus 2 over 3, close it, less than or equal to 0.01. I'm going to multiply by 3. So now I have absolute value, x minus 2 is less than or equal to 0.03. Here's where you're going to stop. That's your delta right there. But I'm going to continue it because I want to find how close does x have to be. How close does x over 2, oops, I did say x over 2. How close does x need to be to 2 so that the error will be 0.01? Oh, I already messed it up. This doesn't matter. I'm going to move the 2 to the other side. Actually, no, I'm not. I'm going to stop. That's my answer. If you were to solve it, if you were to continue to solve it, you would do this. X less than equal to, less than equal to, and then plus 2, so 2.03. And then what's 2 minus 0.03? 1.97? So yeah, and it's really how close does x need to be to 2 so that the error will be 0.01 from 2/3. There, that's the correct analysis. Okay, cool or not cool? This is how close x must be. If you're between 1.97 and 2.03, you will have an error less than 0.01. You guys don't find this exciting? Okay. Yeah, how close does x need to be to 2 so that the error will be 0.01 from 2/3? That's the correct English and the correct whatever. Is this tested on the AP? No, but is it tested on UH? Yeah, so this is going to be found on UH quiz 2. So does everyone see how to do it? Okay, where are you going to stop? In this step right here. This is your delta right there, 0.03. Which is 0.03 is 3 over 100, right? Okay. All right, don't worry, guys. We're almost done. We'll just have a few questions now. Questions 1 through 4, we're going to be using this piecewise. What is the limit as x approaches 1 from the left? Which one do I use? The top or the bottom? Top. What's 2 minus 1? 1. There it is. Done. You're just approaching from the left. What is the value as x approaches 1 from the right? Which one do I use? The bottom. The second one. What's going to be my value? 3 over 2. Plug in a 1 for the x. It doesn't equal, so be careful. Do I ask that question next? Nope. What is the value as x approaches 1? Do they match? Does not exist. But I do ask, look at number 4. What is the value of f of 1? 1, because that's where the equal sign is at. How do you feel? All right, so I think I do have circuits for you, but I think we need more experience, so I put more deltas so you can get more experience. So let's do the deltas first. I'll pass out the circuits, don't worry. And on Monday, we'll make Monday review with circuit day, and then on Tuesday, we'll open it up to whatever questions you may have. Let's try to do it before, man. Well, see if we can before the test.
On the 10th or like
Let's before Wednesday.
like an attempt or
Both.